Hello everybody, today we are talking about objective 1.7 combinations of functions in composite functions. So let's talk about domain first, how to find functions domain. Now domain is, we already know domain is all x values. I'm just going to write here x values in the bracket. Okay. Now, if you have a function that doesn't have restrictions, then domain for that function is all real numbers. For example, if I have a function f of x equal, this is just an example, f of x equal x squared minus 1. If I have a function like this, you know, any number you plug in x, you're going to get something. So it means all real numbers, in this case, is my domain. Now, what is not acceptable in domain is 0 in the denominator, 0 in the denominator. For example, undefined function, like if you have a rational function, then you know you have to be very careful in the denominator, because 0 in the denominator is not acceptable. Like okay, let me write it down. Cannot have 0 in the denominator, and also square root of a negative number. Square root of a negative number is not okay, is not acceptable. You cannot have those. Okay, so let's do some examples here. For example, you have, this is example number 1, find the domain of g of x, which is 5x over x squared minus 49. Now, if you pay attention closely, I'm looking for domain actually, closely pay attention. I plug in anything in the numerator, like for x, you know, I'm going to get something out, like I'm going to get some value. So it doesn't matter what I put there, it's okay. It's not a trouble. So numerator I'm not worried about. Let's try the denominator, because the numerator is not going to make a undefined or negative square root of negative number or anything like that. Anything you put in there, you will get something out. But when you put denominator, like for example, x squared minus 49, so that's why most of the time in rational function we ignore that numerator, because it's going to work. But the denominator we are very concerned. So if I make this equal 0, then it will give me x squared equal 49. And this is going to give me x equal positive negative 7. And you know I square root that both sides. This is what I'm getting. Okay, if you plug in x 7 here, 7 times 7, 49, 49, subtract 49 is going to be 0. Okay, so it's making the rational function undefined. If I plug in negative 7, it will give me the same thing. Okay, so how do you write the answer for domain if the question is asking? You have two different ways. I mean, you have other ways too, but I'm going to show you two different ways. You can say domain is equal all real numbers except x equals 7 and x equal negative 7. Okay, you can do that. Or you can say domain is equal, but before I give you this notation, I want to draw a number line. You know, this is negative 7, that's positive 7. Negative 7 and positive 7 up here, it means if I have a graph, like this is negative infinity and this is positive infinity. If I have a graph up here from negative infinity, like I'm just going to draw a graph, negative 7, either you have a hole, or negative 7 you have a vertical asymptote. So I don't know what do I have right now. We will learn this in further more videos, but either I have a hole there or either I have a vertical asymptote on negative 7 and still goes because these two are the ones that doesn't work for the function as a domain. Okay, so for example, if I have a graph, right, this is a graph, I'm just making it up. Okay, then they're up here. Okay, let me erase that. Let me make it just a little bit proper. So for example, I have a graph. Okay, the graph stops right there. So I have a graph from -infinity to -7, but -7 is not included because either I have this hole and I have a vertical asymptote. Again, the graph started, it goes there, the graph started, it goes in this direction. That one goes in this direction. So how do I write? I mean, just imagine when you get the numbers that are excluded from the domain, then make a number line and do something like that. So it means, the notations I'm writing, -infinity to -7. And since -7 is not included, like it's not working, either whole or vertical asymptote, so I'm going to make this parentheses. And -infinity and +infinity is going to have this parentheses anyway. Another order pair or another not order pair, intervals are -7 to 7. Another one is 7 to +infinity. Do you see that? So these are the places that we have a graph. And I'm mentioning that -7, +7, they are not included because of the parentheses. And you can connect them by making that as a U. Okay, so that's what I have. Now I'm going to show you some properties of the sum, difference, product, and quotient of different functions. Okay, so for example, I have a sum. I have two functions, f and g, and they are adding of x. Okay, and then how do we rewrite this? If we rewrite this, I'm gonna get f of x plus g of x. You see that? These properties are very useful because if you get something like this, like combining the functions, then you can rewrite them like this and it will make it easier to solve. Then I have a difference equal, I have f minus g parentheses and x. And I have f of x minus g of x. Again, very good, very nice if we have in this way. Product, remember, memorize these properties. I have fg multiplying two functions and I have a x. Then how do I do that? I can separate them. I can do f of x times g of x. This is times. Okay, we have one more, which is a quotient. That's a quotient. We have f of g and I have x. Okay, this is going to change into f of x divided by g of x, and we are good. And make sure in this case g of x is not supposed to be equal 0 because it's going to make it undefined. Okay, let's try some of the examples here. Okay, this is my example number 2. I have a function f of x, x minus 5, and I have a function g of x, which is equal x squared minus 1. Find each of the following. Okay, so A, I'm looking for f, the sum of the function, like that. First, find this. The second one, part B, is asking domain. Find domain of this combined function, which is f plus g of x. So these two questions I have to answer by using these two functions. Okay, let's try this. Okay, if you see, if you look at this like that, it doesn't make sense unless you apply that property. Property would help you big time, like I said before. So I'm going to apply the property, and my property look like this: f of x plus g of x. Do you see that? This g is like multiplying with f and g both. I'm sorry, this x is multiplying with f and g both. So this is what I got. So now let's see, what is f of x? It's x minus 5. and I'm going to put the parentheses around. We have a plus sign right there. Then I have a g of x, parentheses again, x squared minus 1. Now, to get rid of the parentheses and combine the like terms, if we have any, then we can solve this. And you know, this addition, when you have addition in the middle, it doesn't change any signs. In the subtraction, you have to be very careful. So if this is addition, you know, I'm still going to show you I'm multiplying this. Okay, so positive times positive x is going to give me positive x squared. Positive times negative is going to give me negative 1. Okay, so let's try. X minus 5, positive times positive is positive, x squared, positive times negative is negative, and then 1. You can imagine 1 here, like invisible 1 here, and you can distribute. Either way is good. So we don't have like terms, like x squared and x are not liked, so I'm just going to put them in order. And we always try to put them in order, like the greatest degree first, and then you go from there. And I have negative 5 and minus 5 negative 1. It's going to give me negative 6. So this is my answer for that. Part B is asking the domain of this function. Okay, let's see one by one. This is a combination of f of x function and g of x function. So let's look at this way. The domain of f of x. Do you know the domain of f of x? Any real number. Remember I said that if you have a function like this, then all the real numbers are your domain, because there is no restrictions. You put 0 there, it's not making undefined, it's not making the square root of negative number. So it means there are no restrictions for this. So you can say f of x function, the domain of f of x functions. Okay, domain of f of x has no restrictions, right? By restrictions, I mean like it's if I plug in 0, does it change anything? Is something going to happen? Is going to make the function undefined? No, nothing. So no restrictions. Now I have a domain. Look at the domain of this g of x function. G of x doesn't have, I'm not, okay, you know, denominator is out of question because it's not a rational function. But look at that. If I make x squared equal 1, then square root x both sides, I'm going to get positive negative 1, which means I'm not getting a square root of negative, which was big no. So it means I'm okay. Domain of g of x has no restrictions either. Okay, so if you don't have any restrictions, then what is your domain? Domain of the function, like the combined function, that one is equal negative infinity to positive infinity. So we're good. Let's talk about composition of a function. Okay, composition of a function. Composition of functions. Composition of functions means, for example, if you have a function f in g, like you have a function f in the g, then we write this for the composition something like this, f, and you have this circle like a 0, O, G, and it's defined by the equation, something like that. Okay, I'm going to show you that. Okay, how do I pronounce this? First, we have to learn that. So it means f, this 0, O, whole, whatever you call it, this means f compose G, not of. F compose G of X. That's how you say it. Okay, so how do I write this? Like f compose G of X, like this. You have to rewrite this like it's, you have to do this like I said, properties. If you use them, that's good. So this is really good when you do this. It will make more sense. This f stays as an f. Do you see these two are like a close together? That's what I mean. I'm observing and do it. So it's going to go g of x like that, which means gx is input. And I have a function f that I'm going to plug in that gx in the f function. Okay. Another one thing is you have to be careful about the domain of composition, domain of composite function. Domain of composite function, first thing you have to remember. Okay, I have to erase that. First thing you have to remember, x is in the domain of G. And second, g of x is in the domain of f. Do you see that? Which means I'm talking about this x is in the domain of G and gx is in the domain of f. That's the rule, okay, for the finding domain of a composite function. Let's do that. Now let me give you example for this. This is example number, what number? I forgot. That's example 2, then this is example 3. F of x function that I have is equal 5x plus 6. G of x function is given, which is 2x squared minus x minus 1. They said find f compose g of x. Okay. Now, remember, we have to rewrite this. Otherwise, we don't understand what to do with it. Maybe some people does, I don't. So I'm going to go f g of x. I always rewrite questions. If we have properties, I do that. I use them. So this is what I have, okay? So it means, if you guys pay attention, I have a f right there, and I'm going to plug in g here, which is my input, 2x squared minus x minus 1. Now let's find what f is. F is right there, which is 5. For the x, I'm going to plug in 2x squared minus x minus 1 plus 6. Okay, this is what I got for f g of x. Now let's solve this. Distributive property, 5 is multiplying with all 3 terms that we have inside the parentheses. So 5 times 2 is 10, x squared stays. 5 times x, like positive 5 times negative x is going to give me negative 5x. Positive 5 times negative 1 is going to give me negative 5 plus 6 stays. Do not multiply 5 with 6, by the way. Okay, so I don't have these like terms, like 10x squared and 5x are not like terms, but I can combine these and I'm going to get 1. If you pay attention, this whole thing, if I'm asking a domain of this composite function, I have a parabola. Do you see x squared? I have a parabola. If I have a parabola, then it means it's all real numbers. It's going to go negative infinity to positive infinity. And no rational, so it's not making a 0 in the denominator, not making a negative square root, so we're good. That's the domain. Okay. Let's go for, I have second example, which is a rational function. This is example number 4. F of x is given 4 over x plus 2. G of x is given, which is 1 over x. The question is asking, find this. F compose g of x. Okay, before I start this, let me give you one more thing, okay? I want to write it down up there as the notes. Okay, so you can copy down. Okay, you know that f compose g of x and g compose of f x, they are not the same. Sometimes the student may mix them up, like they said, okay, it's just multiplying. Multiplication, you can have something like if we multiply 1 times 2 or 2 times 1, it's going to give me the same answer. That's not how it works in here. So this is not the same as that, not at all. Because look, if I change this to my, this is what it is, right? These two together, so I made them this. Now in this case, these two together, look at this, right? like that. This is something that I have in my head, and then it just works like that. So gx is input, up here is f of x is input. So it's completely different. So please don't mix them up, okay? Completely different things. These are different. These two, they are different. Okay, let's go back to our example. Now here's the example. I'm going to rewrite this before I do anything. I'm going to have f compose g of x equal f g of x. G of x is my input. So let's plug in, what is g of x? It's 1 over x. Now I'm going to plug this in, 4 over 1 over x plus 2. So let's solve this. 4, I'm going to keep it, not yet. I'm not doing anything with it. Look at the denominator. Do you see this? The denominator, if you have one fraction and you have another, just a regular term, you can make it a fraction, like put 1 under this and then find the least common denominator. When I see fractions, I just least common denominators in my head. I have to do it somewhere. So x is the common denominator. Then when you cross multiply, it's going to give me 1 plus 2x. We can change this 4, change division to multiplication right there, and you do the reciprocal, which is x over 1 plus 2x. Reciprocal means flip them, like flip it. Numerator goes, the denominator goes in the numerator. Now this is a multiplication, so you straight across just multiply. So I got 4x over 1 plus 2x. So that's my composite function for f gx. Okay, now let's find the domain of this. If we look for the domain, we have to be paying attention for the domain. Remember, the top portion doesn't matter, right? Anything is going to work. What about this? 1 plus 2x. So we always worried about the denominator part, right? So if I'm making a denominator equal 0, it's going to give me 2x negative 1, right? And you divide 2 both sides, and it's going to give me x equal negative half. Now, this negative half will make my denominator 0, which means this is excluded. All real numbers excluded negative half. Okay, so that's what happened there. Now, if we look back and you check the domain for g of x is x equals 0, right? So this is the domain of the one I'm talking about, the negative half. Now let's do the domain of g of x, which is 0 in this case, right? Make the x equal 0, it's going to be 0. So 0 is excluded because it's making it undefined. So if you guys go back to the notes, you see this? Domain of a composite function, x is in the domain of g. So x is in the domain of g. This is the domain of g is 0, right? The domain of composite function, the domain of x is not 0. I'm so sorry. The domain of g of x has all real numbers except 0. This one, all real numbers except negative half. Okay, so I'm just combining this. G of x is in the domain of f. So that's f. The f domain is negative 2, right? And g of x domain is 0. So we are okay so far. So let's do the find out and how to write the domain of the composite function. So I have negative half, and we do care about this one, like the g of x, like according to these steps. G of x is in the domain of f, x is in the domain of g, so we are gonna find the domain of g of x, and we're gonna find the domain of the negative, the composite function. So I have 0, and I have like 1 over x, which was g of x, and I'm going to make x not equal 0. So we need this and we need this. So let's draw a line. I'm going to write the notation in the order pair kind of thing, like the interval notations. This is negative half and this is 0, for example. So look at this. I have a vertical asymptote E, or I have a hole there, okay? We don't know that. So I have a function right there, stop. I have a function right there, stop. I have a function right there, goes in this direction. So it means I'm starting negative infinity to negative half. Then I'm going to go negative half to 0, and then I'm going to go 0 to positive infinity. And these two, negative infinity, positive infinity, is not real numbers. So that's why we have these parentheses like this for negative infinity, and they're not included. Then I have a, sorry, not 0, negative half. And negative half is not included either because we don't know what the stuff is there. Then I have negative half to 0. And then I have 0 to positive infinity. And all of them connected by U, which means that's a union of that. Okay, so these are all my domains, and I have to write there D equal, which means that's a domain. Just be careful. Make sure that you know, try to understand this one. If x is in the domain of G and G of x is in the domain of F. Now the F domain was all real numbers except negative 2. Do you see that? Okay, I'm just repeating myself. I'm sorry for that, but I just want to make sure that you understand really good, guys. Just connect these, okay? G of x is in the domain of F. This is the most important one. I always look for that one, okay? So this is G of x. If I'm doing composition, this is G of x. G of x not excluded is 0. I mean, excluded is 0. And all real numbers except 0. This one is all real numbers except negative 2. So do you see the G of x domain is in the domain of F? Like G domain is in F. Like this is negative 2. All real numbers except negative 2. This one, all real numbers except 0. So that 0 is going to come up here and work. Like if I do 0 plus 2, I'm going to get plus 2. So I'm not getting undefined. I'm not getting negative square root. So I'm okay. That's what it means. The G of x domain is in the domain of f of x. So that's what it means. Okay. So it works here in this question. So that's why I picked G of x, which was 0. And I picked the composite function, which was negative half. And you can draw a line, a number line, whatever you want. If you guys still don't understand, please comment below. I will explain it further with more examples, and we'll figure it out. Okay, thank you guys. Bye.